To understand how VPNs work, we must first fully understand the concept of tunneling. Tunneling is the process of encapsulating network protocol packets inside the protocol of another packet. This process of encapsulation creates the illusion of a tunneling process. The tunnel is to secure communications from point A to point B whilst traveling over an untrusted intermediary network. This tunnel is a virtual tunnel, meaning encapsulation and decapsulation occurs on either end of the tunnel depending on the direction in which the packets enter and leave the tunnel. Now, an intermediary untrusted network may be the internet itself. A VPN can help by providing several critical security functions through this virtual tunnel, such as access control, authentication, confidentiality, and integrity. Important note: whilst most VPNs use encryption to protect the encapsulated traffic, encryption is, however, not necessary for the connection to be considered a VPN. A VPN is an example of a virtualized network. VPNs are most commonly associated with establishing secure communication paths through the internet between two distant networks. However, VPNs can exist anywhere, explained later in the video. Now, let's use an example analogy to explain how two distant networks, aka cities, can connect securely with each other using a secure VPN tunnel. Let's picture that we have a delivery truck that contains expensive items that need to be shipped securely to the other city. Therefore, we need to secure the path using a VPN tunnel, meaning the truck driver will be taking the tunnel path all the way to the city instead of any insecure, unknown back roads. The truck going through the tunnel is like data transmitted from one system to another across a VPN link. The normal LAN TCP IP traffic is encapsulated, encased, or enclosed in the VPN protocol. Again, to recap, a VPN is most commonly associated with establishing secure communication paths over untrusted networks or routes between two different networks, aka cities. An important technical security keynote. Remember the CIA triad: confidentiality, integrity, and availability. Well, what does the VPN provide in terms of this triad? The answer is the VPN provides confidentiality and integrity. This is why the trucks are queuing up to enter the secure VPN tunnel. But remember, VPNs do not provide or guarantee availability, aka a truck getting stuck in the tunnel. Availability can be improved, however, through the use of a VPN concentrator, which is a dedicated hardware device designed to support a large number of simultaneous VPN connections, often in the hundreds or thousands. You can think of a VPN concentrator as adding more tunnels to enhance the original VPN tunnel, offering higher performance, higher scalability, and of course higher availability, meaning more trucks can go through the tunnel at once. An important technical terminology keynote: a VPN concentrator can be referred to by many different names, such as a VPN server, gateway, firewall, remote access server, device, proxy, or appliance. Thus, the use of VPN devices is transparent to network systems. Therefore, individual hosts do not need to support VPN capabilities locally if a VPN appliance is present. Another feature of VPNs is known as always on. To explain this concept, imagine a particular truck driver prefers a specific tunnel route. That truck driver could use an always-on VPN which attempts to auto-connect to the VPN service, aka the specific tunnel, every time a network link becomes active, aka the truck driver arrives at the tunnel entry. Everything discussed so far in this video is known as a full tunnel. But there is another VPN configuration known as a split tunnel, which allows a VPN connected client system, i.e., remote node, to access both the organizational network over the VPN and the internet directly at the same time. The split tunnel thus simultaneously grants an open connection to the internet, e.g., some traffic is offloaded to the VPN client and routed to the public network directly, e.g., YouTube streaming, which is performance over security. This is usually considered a security risk for the business, since when a split tunnel VPN is established, an open network pathway exists from the internet through the VPN client to the local area network. Whereas in full tunneling, all the traffic from the VPN client is routed and controlled, aka filtered, by the VPN server. Meaning full tunneling focuses on security over performance. In simpler terms, imagine that a split tunnel allows rogue or bad lorry drivers to enter our secure tunnel, which means they can ambush or steal from our truck drivers carrying the expensive items, and they can even enter the other city at the other end of the secure tunnel. However, this scenario can be further expanded. Remember earlier in the video where I said there are multiple uses for using a VPN, which is not always city to city, aka two separate distant networks. They can also be used within private networks or between end user systems connected to an internet service provider. The VPN can also link two networks or even two individual systems, such as clients, servers, routers, firewalls, and switches. VPNs are also helpful in providing security for legacy applications that rely on risky or vulnerable communication protocols. So, to conclude this video with a final bonus tip, there are many common VPN protocols that can be implemented using either software or hardware solutions. In either case, there are several common VPN protocols, such as the point-to-point tunneling protocol, the Layer 2 tunneling protocol, SSH, OpenVPN, i.e. TLS, and the IP Security Protocol, IPsec. In an upcoming video, I shall discuss all these protocols in more technical detail, so please be sure to like and subscribe if not already to this channel to ensure you do not miss any future content of cybersecurity explained like I am a 2-year-old.